Everyone, so now we will discuss redox reaction, the fourth segment, synopsis. So redox reaction means the reaction in which oxidation and reduction occurs simultaneously. So if any reaction, if oxidation is happening, means in that reaction reduction also will happen, except that electrochemistry, you know that in that oxidation half cell and reduction half cell separately happens. So that oxidation means, in nutshell we can define that whenever oxidation number is increasing means oxidation happening, means if that element oxidation number moving from number system left to right, then oxidation is happening. And in reduction, if from number system if we are moving left to right, means oxidation number is decreasing, means reduction is happening. So oxidation number and valency, what is the difference between that? So oxidation is a residual charge. Whatever during bond formation, whatever that charge appear on that particular atom is called its oxidation number. It could be positive also, zero also, fractional also, and it is variable because that element of that compound, it associate with different atoms, so may different residual charge appear on it. Whereas valency is the combining capacity, means it is telling that how much any atom during bond formation, how much bond it can form, is telling about that. Like oxygen, it is O minus, that oxygen O minus 2. So its valency is how much? Valency is 2, oxidation number is minus 2 in oxide form. So valency is, for non-metal, how we calculate? 8 minus valence electron. So 8 minus oxygen having 6 valence electron. So total it having valency is 2, means it can form only 2 bond. And it is fixed value and it is actual value. Not like this, it is variable. So here now next difference between oxidation number and oxidation state. So oxidation number and oxidation state, you can see here MnO4 minus 1. So here manganese having plus 7 oxidation number and oxidation state both. Similarly in H2O2 also oxygen having minus 1 oxidation number and oxidation state. Whereas in Fe3O4 ferroxide, iron is plus 2 and here iron is plus 3. So iron oxidation number is, with respect to this, is plus 2 and with respect to this it is plus 3. Whereas oxidation state is plus 8 by 3. So oxidation state is average value. This is total charge by total atom. So here that oxidation state of iron is plus 8 by 3, but oxidation number is respectively with different iron, it is different. Now while calculating oxidation number, you should know some of the elements that oxidation number, like fluorine in halogen family always show minus 1, whereas the remaining all those chlorine, bromine and iodine, they shows minus 1 to plus 7, but fluorine always shows minus 1 because it is second period element. Similarly oxygen, it shows from minus 2 to plus 2, except after this oxygen, other in this family, sulfur, selenium and all, they shows minus 2 to plus 6. So their oxidation state will extend because they are third and fourth period respectively. Similarly, here you can see that hydrogen having also variable oxidation number. With metal, it will show minus 1 like alkali metal or alkaline earth metal. And with non-metal, always it shows plus 1. So by knowing this all those, it will help you to calculate oxidation number as we discussed in classes. Next, maximum oxidation number. How to calculate maximum oxidation number of any element? It is equal to its valence electron. Like chromium. Chromium having valence electron is 6. So its maximum oxidation number is 6. Manganese. Manganese maximum oxidation number is plus 7. Similarly, we can calculate minimum oxidation number also. So minimum oxidation number is valence electron minus 8. Like for non-metal, how we calculated valency? 8 minus valence electron, opposite of that. Minimum oxidation number, how we can calculate? Valence electron minus 8. While calculating oxidation number, when we will add oxidation number all sum in algebraic way, it should be, if it is neutral, it will be equal to 0. But if it is ion, cation or anion, so in that sum of oxidation number of each element is equal to net charge present on it. According to that, we can calculate elements oxidation number. While calculating in this algebraic method, sometime we will get like H2SO5. In that sulfur oxidation number, how much will come? 10. So if sulfur oxidation number is coming not 10, it will come 8, but sulfur is plus 6. So if it is coming 6, if it is coming plus 8, means algebraic method by which we cannot calculate. So by a structure we can calculate. So some of the compounds, a structure you should know. Like for that, all those H2SO4, H2SO5, H2SO3, H2SO6, S2O6, H2S2O7, H2S2O8. These are all those we studied in classes. Here you can see some important and those examples which we cannot calculate oxidation number by algebraic method. Like here you can see CrO5. So here you can see this is peroxide, this is peroxide, and this is oxide. So chromium is here, this oxygen is -1. So overall this is -4 and this is -2. So chromium +6 and chromium maximum oxidation state also +6. So a structure will always tell accurate oxidation number or residual charge on that particular atom through that structure, but maybe sometime by algebraic method will get or sometime will not get. Here I told also that here you can see that this is 3-membered ring. It is unstable according to Bayer strength theory. So this is stable only in presence of ether solvent. Ether will give its here lone pair to this, that in ether oxygen is ligand. So oxygen will give its lone pair through coordinate bond. Then it will be stable somewhat. Here you can see K3CrO8. So in that crisscross method, so chromium CrO8 -3. So again here you can see that how many sets of peroxide linkage are there? 4 sets. So overall this is the structure. Potassium tetra per oxochlorate. Similarly here Br3O8. So Br3O8, in that you can see bromine, bromine, bromine and bromine. So this side 3 oxide, this side 3 oxide and this side 2 oxide. Since this bromine is symmetrical with respect to left side also and right side also, so here that charge formation will not happen for this bromine, because this side whatever that group is there, whatever electron they will attract this side, that much only they will attract also. So overall this bromine having no charge appearance here, no residual charge. So overall due to this 2 oxygen it will be +4. Here remaining this side terminal 6 that 3 oxygen, so it will be +6, and similarly here also +6. So to calculate its oxidation state, because this all those are oxidation number of bromine, so oxidation state is total charge by total atom. So total charge 6 + 4 10 + 6 16 divided by 3. So it is 16/3 is oxidation state. Okay. So by algebraic method you can get oxidation state accurately, but oxidation number on per that bromine you might not get. So by a structure only you will get that. Here very famous and very important, that carbon suboxide, you can see carbon, carbon, carbon. Here all 3 carbons are sp, is not double bond, triple bond. And here it is this oxygen, here it is -2, so this carbon is +2. This side also here it is -2, so this is +2, and this is symmetrical, so 0 charge. If any in that compound, if particular atom, particular element, if it is at maximum oxidation number, means it is called oxidizing agent. It will behave as a oxidizing agent only, and it is also called oxidant, means it will do oxidations of other and it will reduce itself. Similarly, minimum oxidation number means it will behave as a reducing agent, or reductant means it will reduce others and it will oxidize itself. But those whose elements oxidation number is in between maximum or minimum, that will behave as a both oxidizing agent and reducing agent. Like here you can see H2O2, H2SO3, HNO2. This all those will behave both as a oxidizing and reducing agent. One very important point, that mixed oxide will always behave as a both oxidizing and reducing agent, means their oxidation number always lies in between maximum and minimum. Like here you can see Fe3O4, Pb3O4. These all those will behave like a Hmm? Both oxidizing and reducing. This is how it is mixed oxide. Already we discussed. Here you can see Fe3O4, in that FeO along with Fe2O3 also there. Similarly Pb3O4, in that also 2 PbO and PbO2, so it will form Pb3O4. Similarly, non-stoichiometric compounds also. Non-stoichiometric, like here you can see it having whole number ratio. So such type of compounds are called stoichiometric compounds. But where whole ratio will be not there, such type of compounds are called non-stoichiometric compounds. So non-stoichiometric compounds are also a mixed oxide, means there also it will behave as an oxidizing agent and reducing agent. Like here you can see Fe0.950. So here oxidation number, you will see that it's when iron oxidation number you will calculate, it is coming in between +2 and +3, means it will behave as a both oxidizing and reducing agent. One very important point, this you keep in your mind, that here you can see carbonic acid H2CO3 +5, H3PO4 phosphoric acid +5, and H2SO4 +6. Even though they are at their maximum oxidation state or maximum oxidation number, still they will not behave as an oxidizing agent when they are in dilute form. If they are in concentrated form, then only they will behave as a mild oxidizing agent, not as strong also. So it's very important, keep that in your mind. Now coming here, that mixed oxide, as we discussed, FeO, Fe2O3 forming Fe3O4. So this is its oxidation state. Here +2 is oxidation number, +3 is oxidation number. To calculate how much percentage of Fe +2 is there, so just you can calculate by atom. Like here Fe atom is 1, total iron atom is 3 into 100. In non-stoichiometric compound, how to calculate how much Fe +2 is there? So here you can see Fe 0.93. So when Fe 0.93O there, so when you are calculating, so how to calculate its oxidation number? You can see that it will be x into 0.93 into, not into, plus -2 is equal to 0. So from here x value will be how much? 200 by 93. So it will lump sum, it will be 2.15 like that. So you can see that its oxidation number is that 2.15 is lying in between minimum and maximum oxidation number, means it will behave as a oxidizing or reducing agent both. Clear? Now here how to calculate how much here +2 is there and how much +3. So for that in class I discussed with you that one general way also we can calculate. For calculation we discuss actually 3 methods. So but I discussed that you can generally use for competitive exam this Brahmastra, because whenever average value is coming we'll use this Brahmastra. So here that Fe +2 is equal to that average value 2.15 minus, because oxidation number is average value, so 2.15 minus, if you are calculating for +2, so here -3 divided by iron +3 minus iron +2, higher valency minus lower valency into 100, so 85%. Clear? Now oxidation number by structure and bonding method. Since you know ionic compound having not bond sort of interaction, so whatever the charge on cation or anion, that is only called its oxidation number. During coordinate bond, that when they will form coordinate bond, so donor will have +1, acceptor will have -1, so that is their oxidation number. But in covalent, that there are different cases, like you can see when both atoms are different, in that let's suppose B is more electronegative, and if A and B having single bond, so B will, let's assume that B is attracting A electron also completely, so here it will have -1 and A will have +1, since B is more electronegative. Similarly, if it is having double bond, so here it will be -2 and here +2. And similarly, if it is triple bond, so B will have -3 oxidation number and A will have +3. In case 2, when both atoms are same, let's suppose A and A only there, then there we will not decide by electronegativity, there we will decide by hybridization. So if hybridization of that atom, both same atom, if it is same, then oxidation number will be 0. But if hybridization is different, so those atom, even though they are same, those having more percentage of S character, it will have more electronegativity. Like here you can see hypo solution Na2S2O3. So if we calculate by algebraic method, you will get oxidation state, that is +2. Understood? Let's calculate. Here you can see sodium is +1, always alkali metals are +1 into 2. As here I told, you can see a little bit. Here, if I am not told, you can keep that in your mind, that alkali metals will be always +1 and alkaline earth metal will be always +2. Always. Understood? It's not going to change. So here coming back, so you can see here, so sodium is always +1, so +1 into 2 plus sulfur we need to calculate 2x, and oxygen is -2, oxygen is -2 into 3. So overall how much? 3 2 is 6, -6 plus 2 plus 4, x is equal to divided by 2 plus 2. So this is its oxidation state, not oxidation number. Now to calculate its oxidation number, we need to know its structure. So here you can see sulfur, double bond sulfur, double bond oxygen, and this side ionic bond. So ionic interaction will not show by bond. O minus Na plus, O minus Na plus. So here sulfur you can see its steric number of sigma bond plus lone pair. So only sigma bond it having 4, lone pair 0. So it is sp3. Whereas here you can see this sulfur, it having 1 sigma bond and 2 lone pair, right? Because sulfur having 6 valence electrons. So 2 electrons are here and remaining 4 is as a lone pair. So 2 lone pair and 1 sigma bond, so it is steric number 3 means sp2. So here this sulfur having percentage of S character, how much? 33%, whereas here 25%. So here percentage of S character is more, means electronegativity of this sulfur is more, means it will attract this 2 electron this side. So -2, here +2, here -2, so this one +2, here -1, so this sulfur is +1. Here this one -1, so this sulfur is +1. So overall this sulfur is +6 and this sulfur is -2. So when you will calculate average, that oxidation state is total charge. So one sulfur is +6, another sulfur is -2, divided by total number of sulfur. So you will get 4/2, means oxidation state is 2, but oxidation number of both sulfur is different, 6 and -2 respectively. So by bonding method, we can calculate oxidation number also. Next one, you can see that hypo solution when is getting oxidized, so it is forming Na2S4O6, sodium tetrathionate. So in that you can see this sulfur, it's symmetrical, both are same atom and they are having same hybridization also. So oxidation number will be 0 because this side also same group attached and this side also same. So there that residual charge will be 0. But for this sulfur we can calculate -2, -2 and -1, means this is +5. Similarly this sulfur is also +5. Overall oxidation state will be again total charge by total atom. So total charge is +5 and +5, 10, 0, 0, 0 only. So 10 by total number of atoms, sulfur 4. So oxidation state is 2/5, means 2.5. So oxidation state is average value, oxidation number is the residual charge during bond formation, and that we will come to know by its structure. Now, redox reaction, as we discussed, that oxidation and reduction happen simultaneously. Loss of electron is oxidation, gain of electron is reduction, or we can say that those whose oxidation number is increasing is oxidation, those whose oxidation number is decreasing is reduction. Always remember, those substance which is getting oxidized, its left part is reducing agent. Those substance which is getting oxidized, its left part is oxidizing agent. Next, coming to disproportion reaction. So disproportion is a special type of redox reaction where single element will get oxidized also and will reduce also, and that single element will have in that reaction 3 oxidation number. So like this is very important example, that halogen in that chlorine, bromine and iodine, fluorine will not show disproportion reaction because it only shows -1. But for disproportion, that element should shows how many oxidation number? 3. So here you can see X2 is 0, that chlorine, bromine, iodine, and if in basic medium hot and concentrated, so it will go to -1 and +5 oxidation. Means -1 means reduction happen, +5 means oxidation happen. And if in basic medium dilute and cold, then it will go to -1 means reduction happen, and +1 means oxidation happen. Fluorine never shows disproportion reaction. Similarly, this one also very important, that phosphorus in basic medium, it forms pH3 and H3PO2 -1. So here phosphorus is going to -3 and here phosphorus is going to how much? 2 2 is 4, -4, and this is +2. So -2 going that side, +2, -1. So phosphorus is +1. So any element, this in nutshell you should remember, if any element is there present at their minimum oxidation number, they will not show disproportion reaction because further their reduction not possible. And those elements who is there present at their maximum oxidation number also, they also cannot show disproportion reaction because further their oxidation not possible. Because for disproportion, what is that they should oxidize also and they should reduce also. Okay. Next, moving further, comproportion reaction is vice versa of disproportion reaction. Okay. Next, now to balance any chemical reaction, like you have studied heat and trial method. So here in our syllabus, that 2 method is there. One is ion electron method and second one is oxidation number method. So here we will just revise that rules, because many questions we did practice in classes. So what I guided you there, that first, that in any chemical reaction, that first you find out, make it in ionic form, means you represent the charge on it by crisscross method, and then after you segregate oxidation half reaction and reduction half reaction, and then after both oxidation half and reduction half you balance first all other atom except oxygen and hydrogen. After that you balance oxygen by adding H2O towards deficient side. Similarly, you balance hydrogen by adding H plus towards deficient side. You balance charge by adding electron. And then after, add both OHR and RHR in such a way that electron from both sides should get cancelled out. And if that reaction is in basic medium, so suppose if 5H plus is there, so 5OH minus you add both sides, then reaction will be in basic medium. In that we discuss molecular reaction also how to balance, disproportion reaction also how to balance. If one in that compound 2 oxidation also happening, then also how to balance. So all those examples you revise properly. Some examples again we will do during NCERT line by line, and then after we will go on for JEE Mains Advanced NEET PYQs. Okay. Here second method by which also we can balance. Here what we have to do, identify oxidation and reduction, that where oxidation is happening and where reduction happening through oxidation number. Then after balance charge, means those atom which is getting oxidized and those atom which is getting reduced. Balance charge by cross multiplication after balancing atoms undergoing oxidation and reduction. Means suppose for example iron is going from +2 to +3, means oxidation difference is what? +2 if iron is going from +2 to +3. So here difference is that 1, correct now? So here that balance charge by cross multiplication after balancing atoms. So first what we have to do, we have to balance those oxidation and reduction atoms which is going for oxidation and reduction. First we will balance both atoms, and then after we will cross multiply their charges, means charge difference, oxidation number difference, and then after we will balance other atoms. Then after at last we will balance oxygen by adding H2O and hydrogen by adding H plus, and in basic medium you can add OH minus. For this we will discuss one example. You can see here, quickly we will revise one. So you can see so oxidation number, you can see that FeCl3 plus H2S forming FeCl2 and HnHCl. So here you can see that iron +3 going to +2 means reduction happening, -2 going to 0 means oxidation happening. So first we identified, then after balance both atoms. So here iron, you can see here iron is 1, here also iron is 1. Next after this side sulfur is 1, this side also sulfur is 1. Then after here +3 to +2 means difference of charge is, oxidation number difference is 1, and here difference of oxidation number is -2 to 0 means 2. Now you crisscross multiply, means this 2 you multiply to iron, and this -1 you multiply to sulfur in left hand side only. And after that you balance all other atom, then after you balance hydrogen, then after you balance oxygen, and then after you balance hydrogen. So here you can see after that iron is here too, so here iron also we need to balance. First iron is balanced, here also I multiplied by 2, so both side iron is balanced. Now you can see chlorine is 6, here chlorine is 2 to the 4, so 1 here I multiplied by 2, so now chlorine became 6. Now after that sulfur, here sulfur is 1, here also sulfur is 1. Now after that we need to balance hydrogen because oxygen is not there, so hydrogen here 2, by default here also hydrogen is 2. So like that we can balance. Here some of the examples, you can take a screenshot and try to balance this also. Okay, so these are the examples 13 and 14 also you see, and try to balance by yourself in such manner only. So here we revised redox reaction completely. Now after this last segment is there, that is volumetric analysis, that is titration. So thank you very much. Revise nicely, study properly.